Well, folks, it's my favorite part of the show. We get to bring in a guest to drop some knowledge on our Quiet Riot, and today is no exception. We have Rajiv Dutt, CEO of Dimensional Mechanics. Rajiv, welcome to the show.
Hello, how are you?
Now, Rajiv, before we try to jump into data, machine learning, AI, our audience loves to hear origin stories. Can you maybe give the audience a quick journey through your experiences in tech up until Dimensional Mechanics?
Sure. Well, I've been coding since about, I guess, the age of 10 or so. I was way back in the day, I was playing games that were not particularly intelligent, and so I decided, okay, well, I wanted to make games more fun. And so I started kind of playing with my first kind of, in quotation marks, AI, which was kind of expert systems sort of approaches, and made games definitely a lot more interesting. And from that point onwards, I just fell in love with the whole concept. So I kept developing and coding, and I ended up actually doing theoretical physics in university. After that, I joined my first company. It was an AI startup based out of London. I worked there for a while. I worked for the BBC in their media group, also doing some AI work. I was then recruited by HP. Worked there for a while, worked again doing a lot of AI work in between. I had my own startup sort of between all these different companies, again in AI, so needless to say, it's been a theme in my life. I've been kind of working in this space pretty much experimenting with everything from expert systems right up to sort of more recently deep learning. I worked for Microsoft for a while as well in the Core OS division. I was hired from there to join Intel. Did some additional work, in this case kind of relating some of the, it was sort of this issue with pre-silicon versus post-silicon, being able to predict whether or not, like how the bugs were related and whether or not you can actually identify issues before even the silicon has actually been etched in a way. So this company was started about 3 years ago. It was sort of it seemed like it was almost inevitable, given everything else that I was doing in my life, that I would eventually do this. It was sort of a childhood dream, and here I am today.
Fantastic. Now, it's safe to say you're probably an expert in this area. You have a little bit of experience in this area. Now, I wanted to first start to help our audience along the way. Obviously, AI and machine learning are big in the enterprise space today, and so what are some of the challenges that organizations are facing when it comes to bringing this into their organization and start utilizing it?
Well, I think that the biggest issue is data. A lot of organizations are simply not ready from that perspective. So let me just, I guess, take a step back and talk about give a layout of the landscape. So on one hand, you have sort of the cognitive service providers. They're kind of the Google and Microsofts. They're sitting on piles of data, and what they do is they train models using ever innovative approaches that they then expose via a service to the rest of the world, so you can make access that via an API call. So that's one side. On the other side are custom models, and this is kind of the 80% part of the market. So most businesses are actually trying to look at building models based on analytic data, and unfortunately, in many cases, it's usually poorly structured. There isn't enough of it, and so oftentimes the models that are built are not really that robust. And so that's one of the major factors. The second, honestly, is skill set. A typical, like I was just talking to somebody the other day, their son just graduated from MIT, has never worked in the tech industry before. His starting salary is $350K. I know that some senior ML people can earn up to like between 1 to 2 million. So it's like the salaries are just absolutely insane at the moment in the machine learning space. So this is kind of the second part. And the third big part, the third major issue is lack of governance and lack of operation. I call it operationalizability. I don't know whether there's a word for that, but what that basically is the ability to control what actually gets into production. So these are sort of governance issues, determining the lifetime of an AI model when it goes out there. Is there data provenance? Do you know where this, how this model was trained? What was the architecture of the model? Does it have a retirement plan in place? So all of these things need to be thought of. And on top of that, how do you integrate that into an IT framework, which is, of course, a big challenge that IT departments in particular are facing right now.
Right. Yeah, I think the interesting thing is a lot of organizations have heard of a lot of organizations. Well, they'll go and say, hey, we have all this data. We want to make use of it. Obviously, it's a smart thing to do, especially for our investors, in order to help new products and advance our services and so on and solutions. So we're going to go pay a company, because obviously we don't have experts in this area. So we're going to go pay a company a couple $100,000, maybe even $250,000, over $250,000 to kind of get this up and running. And then they don't always have a really good return on investment on it. So how is your company, how is Dimensional Mechanics actually helping with that process?
Well, our platform is it's called NeoPulse, and with NeoPulse, NeoPulse itself is powered by an AI, so it's literally an AI that builds AI. And the funny story is this AI that builds AI, part of it was built by the AI, so which is very meta. But what we do is we fully automate the process of building learning models. So that's actually a major piece of that. So by being able to do that, you allow a couple of things to happen. The first is a rapid iteration. So we had a team, for example, come here, and in the course of about a month, they were able to generate 20 different models, just tweaking their data, running a new model, tweaking it, running. Currently, that's not really feasible given the time lags and the length of time it takes to design an architecture and so on, design a new neural network architecture, for example. But with our platform, since it happens automatically, the iteration cycles are really short. Within about 2 or 3 days, you're already ready to try something else, which means that you can experiment. And that's actually that's part of the heart of building good machine learning solutions. So we kind of help with that. Another major issue is standardization of deployment. So one of the things that we really like is, coming from a little bit of my background, is I've also done a lot of work in the enterprise space. And one of the things that matters are standards. And so one of the beautiful parts of what we do, the part I'm really excited about, is being able to deploy to end targets that could be from IoT devices to mobile devices, which means that a company doesn't have to switch to go from one framework to another. With one framework, with a single click, you can basically deploy to any kind of device, whether it's an ARM64 machine or an x86 machine.
So let me take a step back for a second, because I do want to bring the audience through the technology of this. So you said that so for instance, an organization comes along, they have a bunch of data, they want to make use of it, so they kind of come to the company. What do they do to get started? What's kind of the first part of the process for them? You said that you have something called AI Studio, and I do want to get into a question later about how AI actually built AI, but that's later on down the road. I want to first start and think, okay, an organization has data. What do they do to get started? How do they ingest that data? How do they get going? Right.
So right now we have a couple of options. One is we have a cloud. We're on AWS as well as in Azure. So we're available as an AMI. So literally what you do is you have your data, you generate a CSV file corresponding to that data, which could exist on an S3 instance on AWS. You connect it up to your to AI Studio. You write one of the things we did was we created a new language called the NeoPulse modeling language. And the NeoPulse modeling language, we kind of call it the sequel of machine learning, because in 14 lines of code, you can essentially build an entire a model from soup to nuts, basically. And the way that you do this is you'd write your 14 lines of code, you submit it to AI Studio. AI Studio will build the model for you. And then once it's ready for deployment, it wraps it up in something called a portable inference model, which is a construct we've created, it's platform neutral. And you just plop it onto a machine where our runtime is there, so which is called NPQR, so the NeoPulse Query Runtime, and which is also available on AWS and Azure. and from there on, you can basically just query your model without actually writing any extra code. You just literally run one command. The PIM is now instantiated and is ready for querying. So the overall process is kind of think about it as you have your data, you submit it to AI Studio with the NML code, which is basically instructions and what kind of model you want to generate and so on. AI Studio will use the AI to build an AI to generate the portable inference model. Once the portable inference model is ready to go, you just dump it onto a machine with a runtime on it, and the runtime will then allow you to query or interrogate the model without having to write much code. It's just really a REST call from that point. Right. So the REST interface is automatically generated.
So an interesting question for you is, and this is coming from the chat room. So is this like a serverless kind of model? Is this a service that you host? Do you use your own infra? Can you host it in the cloud? Can you host it locally on your network? How do you kind of get this going?
So you have several options. The first is it's available as an AMI on AWS and on Azure, which means that you just run it in your own account. So an AMI basically is sort of a virtual image that exists on AWS or on Azure. So which means that you run it in your own cloud. The other option is we do have an on-premise version.
Oh, cool.
Of AI Studio, so you can install it locally, and we're actually going to be coming up with an appliance very soon, which is a very high-end supercomputer with our with AI Studio built on board. So it's kind of literally plug and play. So you don't really need to do anything about that. And our runtime is basically available again on-premise and on devices, and also available in the cloud as an AMI as well. So you have plenty of choices in terms of how you want to use it and implement it.
Now, you said the obviously AI Studio and the models can be implemented in these different environments. Now, you also mentioned that the runtime can actually run potentially on IoT and Android devices as well, so they can actually process these models on those devices.
Exactly. So it's a low power. So the runtime. So without having to kind of recompile or rebuild the models, you can essentially put them on any kind of ARM device, ARM64 device, or IoT device. In fact, we're currently in conversations with a couple of chip makers to look at ways of developing even tighter integration. The advantage is it's literally like kind of just you build it once, you code it once, and you deploy everywhere. Think Java in the old days. Where the target of Java was to essentially enable broad deployment of applications. So we kind of, and you needed a runtime. So essentially we offer that runtime that allows you to exist at any end target.
Now, for actually doing the code here, you actually mentioned that you have a new language. Now, why did you? I'm actually always curious because I've utilized many backend services, whether it's telemetry services or other data services that do use new languages. Some very similar to SQL, but they produce more kind of functionality with them. Why did you choose a new language, and how accessible is that to current developers or maybe just IT pros?
Well, the reason we created the language was that one of the things we realized was coding in regular Python was tedious, and you're basically repeating yourself quite a bit. I mean, the analogy is like going from assembly language to C. Sure, you can write everything in assembly language, but why would you for many problems? So what we have is, so what NML does is it essentially essentially wraps a lot of these basic capabilities, wraps these functionalities in a way that makes it invisible to the developer engineer. So some of these things, for example, would be pre-processing of the data. It would be marshaling the data for training. Kind of I/O kind of operations. It would be the generation of. We have introduced a new keyword called auto, which basically tells the AI that we call the Oracle. It tells the AI that, hey, I need your help. We're all geeks, which is Matrix. So it tells the Oracle that, hey, I need help here with this architecture. And it comes back and builds the architecture or determines what is the ideal loss function or optimizer or hyperparameter to use for that particular problem. So it depends on the level of granularity that you needed. So the language offers us the ability to write an amazing amount of so to create really complex models with very little code. In-house, NML is used a lot inside our company. It's kind of eating our own dog food, and it's just because of the fact that we save so much time. We don't actually have to write a lot of code to kind of go very far. In terms of how easy it is to learn, we have had Stanford physicians use it, so to actually build models. So these are people with no prior software engineering skills, experience, or machine learning experience, and they were able to kind of build models. And in fact, one of the papers based on our on NeoPulse will be published at the RSNA, so that's Radiology Society of North America. They have a big conference in Chicago every year, and the results will be published there. We've also had high school students use us, so that's pretty cool. And so all of that makes it so it's very easy to learn, very easy to pick up. You can pick it up in an afternoon. To become proficient at it and to really write some advanced code, it is Turing complete. So to write really advanced code, of course, it will take much longer. But to really get going and writing your kind of hello world types of applications, it could learn it in an afternoon. And our hello world is writing a full classification model, so that's more.
Okay. So the interesting thing, so you were saying it's kind of a wrapper around some functionality of the as verbose as Python might be. The interesting thing about Python that I see in the community, especially when it comes to deep learning, is there are a pretty large ecosystem. So there's tons of libraries that do specific things like Keras or MXNet or sklearn, Athenium. Is there some similar, like, do you offer just out of the box functionality that's more higher level, functional aspects of that type of thing, or do they still have to import libraries like that?
So we actually have, a lot of it is already embedded inside AI Studio. So everything that currently, for example, exists in NumPy or TensorFlow or something is accessible through NML. So you could write arbitrarily complex code and actually leverage sort of the best of breed if you wanted to, and really write your own layers. And you could definitely do that. And a lot of the underlying functionality is accessible. Like you can make function calls to that level. Just as you can, for example, write assembly language in C, you can also kind of make underlying calls to TensorFlow if you need to, but for the most part we don't need that, because most of the complexity has been already wrapped up, and you can leverage. So you don't need to. It's very rare that you need to go down to that level, that you actually need to do anything like that.
Rajiv, this is some really interesting stuff, and I know we've actually talked a little bit about organizations, how they actually ingest their data in the system, how they get it processing, how they write their models, and how they can actually program using this NML language that you actually have. I did want to ask one other thing. So you talked a little bit about how you can actually export these models. Now, are they in a standard format, or is it in a special format that are just kind of used and available for the runtime that you support, or are they models that can be ingested in other systems?
So right now the model, it basically exports it into a format that requires our runtime to access. And the reason for that is, we have a lot of reasons actually. One of the reasons is firstly security, because if you want a real runtime deployment, sometimes you may not necessarily want to reveal the underlying architecture to the end user. So this could be what you'd end up doing is you'd build it in AI Studio. It encapsulates it. You can potentially hide it from whoever's using it. We give you the opportunity to include the architecture design in the actual document, in the actual PIM file, but you don't need to. In addition to that, there's a lot of other metadata, which could include things like provenance, author, location, functionality, description of the data, all kinds of additional things that you think that would be relevant, so that you can build trust. Also versioning information, all that you can build trust in terms of the PIMs that are generated, and which unfortunately there isn't really a very clean way of doing that by just simply leveraging external or outside applications. Down the line, we may opt for a different, we may expand it out to allow execution in other environments. But right now, the neatest way is to essentially require our runtime, because it makes it a lot easier to kind of protect your assets, to control like to ensure that you've got the right amount of metadata going across for governance and management purposes. And the runtime also itself exposes a set of REST APIs that allow you to manage models that are currently in production as well. So it offers a whole set of additional services on top, which basically make it very easy to control what's actually in production and to implement life cycle strategies and things like that.
Got it. Well, I do want to bring my co-host back in because they have some pretty great questions. They're chomping at the bit here in the chat room.
Sure.
Curtis, I want to start with you first. I want to get your thoughts on from the enterprise space kind of point of view.
Well, my first question is a little bit technical. You're talking about the whole idea of AI training AI. And as you pointed out, training these engines is really the most expensive part of any deployment. My question comes to training bias. If you have an AI training another AI, don't you have the opportunity for a situation where you end up amplifying a training bias, where the bias of one AI is amplified as it trains another?
So the short answer is yes. That's always a risk. But one of the things that we do is, there are a couple of mitigations that we have. The first is we look at the underlying the data itself, because that's usually where most of the biases in the models come from. It's like whether or not your data is correctly balanced, whether there are any anomalies in your data that should be removed, and things like that. So those are the kind of decision points that need to happen kind of before you even kind of start training. So we're in the process of working on a set of tools and technologies to allow people to determine and, for example, establish whether or not your data set is balanced, to be able to determine things like whether there are anomalies in your data, if you're trying to do time series, to see if your data is stationary, to make sure that there's just not that you're not looking at just noise, to do basic things like that, which are things that you can do to essentially remove bias or identify kind of trends or underlying patterns in your data. Once it actually goes through that, and you have, and once it goes through this analytics suite that we're creating right now, the AI takes over at that point and will build your model for you. The thing to think about, though, is that the AI itself gets better over time. So, I mean, the whole part of the logic that we have is that over time there is self-improvement. So it actually gets better. It actually develops. So there's a mechanism in place for it to learn from its mistakes. And so this is something that over time, in some subsequent versions of AI Studio, what we'll be doing is exploiting that even more, and actually talk about AI like Oracle of Oracles. So something that can essentially learn from the mistakes of a lot of designs and try and kind of like build up a master suite of things that of highly functional models for a company. Does that answer your question?
No, that's great. My other question has to deal with some sort of foundational definitions. We've been using the terms machine learning and artificial intelligence here in the conversation. Mm-hmm. From an operational standpoint, how do you distinguish between those two? I mean, marketers tend to use them, but do you make a distinction that makes a practical difference between the two terms?
Well, machine learning, so AI includes a lot of different techniques, some of them which are procedural, some of like you have sort of direct, like more, I mean, they're everything, things like, for example, k-means, PCA, these are all could be examples of machine learning. But I mean, if before that, even if you just talk about AI, I mean, expert systems are a type of AI. So then if you go beyond that, then you've got machine learning where the actual system develops additional capabilities as a result of without being explicitly programmed. And then if you go further than that, like deep learning is a subset of machine learning. where it's just another approach to kind of, it's another machine learning problem. So from our perspective, AI is the overarching bucket, which could include everything from procedural to machine learning kinds of algorithms, and then machine learning is a subset of AI. So that's kind of like what our operational definition is.
Fantastic. Now, Bam, I know you had some questions about implementation.
Yeah, so I always like to bring our guests back to what I think our audience cares most about is what are the kind of outcomes the enterprise IT professional can expect from an implementation in NeoPulse? For example, is this something I could apply to the large volumes of log data to determine maybe do I have an insider threat roaming on my network, or maybe there's some sort of attack mounting coming from outside my network that maybe I should put some sort of countermeasures or additional sensors in place based on what NeoPulse learns and tells me about the data that I have available.
Well, I think the answer is we basically work with many different types of data types. So we work with audio, video, text, images, as well as kind of classical vector data, which would be sort of straight numerical. So the regression or time series types of problems as well. So we work the entire spectrum, and including now actually medical data. And very soon also some other, we'll probably announce that in about a month's time, some additional data types as well that we are starting to support. But in terms of the volume of data, so we've actually worked with like one large network appliance manufacturer, and to predict things like CPU utilization on machines to actually determine whether they're out of whack with what's expected. We have done work with large volumes of like financial data to actually make predictions on the volatility index market. We have done work in sales predictions, so forecasting the next quarter sales. So the volume of data can be pretty can vary quite considerably. So on one extreme you have kind of sales kind of forecasting data. On the other extreme, you have like large volumes of data coming in from kind of network or infrastructure behavior and things like that.
And so specifically on that last point about network or infrastructure data that might be coming in, do you have any specific examples? Because that's something that I think our audience would really love to hear about, is a specific example where this was applied to the enterprise IT infrastructure and to maybe find efficiencies or other gains.
Well, we're currently, and this is unfortunately the case with a lot of machine learning projects, is that a lot of these things are kind of in POC stage, but we do have a couple of POCs going in this space. One is basically to look at, and it's with this network company that we're talking with, who we're currently working with. They're looking at, for example, CPU behavior in their network infrastructure. So which means identifying like utilization of machines, and making predictions about whether or not a machine is operating within expected parameters, or whether or not a machine is exceeding the limits of what it should be, basically. The second one is also on data center energy consumption. So in this case, there are several approaches. For example, being able to identify whether machines are idle or whether they are actually being used, because even an idle machine, there's a ton of traffic going back and forth, and it is being utilized in some way. But is that utilization real, or is it as a result of background operations? And so being able to determine things like that. By identifying those kind of elements, you could potentially lower the cost of data center costs. And there are many other things you can do as well. So those are some two examples in the infrastructure space that have recently come to, that we're recently looking at. There have been some additional types of work, which I unfortunately can't go into a lot of detail with, is in the smart city area. So with sensors and with data coming in from large smart cities environment, as well as in kind of the fog computing space as well.
Fantastic. Rajiv, unfortunately, we run out of time, but I do want to ask one last question here. Is Skynet coming?
I don't think so, but I think we're quite a ways off from that. But all I can say is that when our AI starts to, it is writing itself, and it's getting better, and it's going to be more involved in its own creation. And so it'll be interesting to see what comes out of that.
Fantastic. Rajiv Dutt, CEO of Dimensional Mechanics, thanks again for being on. Can you maybe tell the folks at home where they can go to get started, learn a little bit more about Dimensional Mechanics and some of your frameworks and platforms?
Absolutely. The best place would be our main webpage, which would be www.dimensionalmechanics.com. You can also do a search for AWS NeoPulse or Azure NeoPulse. You'll get information from that. You can get information about our APIs through docs.neopulse.ai. By the way, if you do a search for just NeoPulse, you'll come up with Samsonite luggage. So it should be NeoPulse AWS or NeoPulse Dimensional Mechanics or something like that. And so those are the best places.
Thanks so much. I'm Louis Maresca saying, if you want to know what's going on in the enterprise, just keep quiet.